Hi, welcome to EnviroTube. I'm here with this gorgeous pygmy python, who's the mascot for the wildflower gardens down at St Ives. But we're not talking about wildlife today. We're going to talk about a problem that does impact wildlife, impacts humans, and all across the globe is a major issue. We're going to talk about microplastics. Microplastics are small pieces of plastic that are either produced to be small or that break down, and then find their way into our waterways, our oceans, and across all of our environments. Whether it's a human or a pygmy python, we're all impacted by microplastics. We're going to learn about it today, and importantly, how we can help scientists in working out the scale of the problem and the solutions. Hey Soph.
Hi Jacob, how are you going?
Good. So we're out here looking for microplastics. I don't see any.
No, they're a bit hard to find. By the time they get washed off the side of the road, down into the stormwater drains, into our creeks, they get all chewed up into tiny little pieces. So we're down here looking in the sand to see how many little bits of microplastics we can find.
So we're going to look into in the actual sand, not in the water?
Yeah, in the sand, in the sediment, and seeing the tiny little pieces that they get broken up into little sand-sized pieces of plastic, and that's what we're going to be looking for.
Oh, let's go have a look to see how we do this.
Yeah, let's go.
We're looking for a couple of different things, but mainly we're looking for those small bits of plastic that people might not even see in the environment. The testing's mainly been designed for sort of ocean sites or on the beaches and the shores of ocean areas and big estuaries, so I've had to adapt things slightly to do the testing on small bush creeks.
So there's a few different problems with plastics. We have the types of rubbish that you see when you walk around, where people have dropped things as they've been bushwalking or that have been washed down the creek. The microplastics that get washed down off our streets or from our shopping centres come down the creeks, where they eventually get into the oceans. We've got this beautiful natural waterway, and it is a shock to find that there are so many plastics that are polluting even areas that look this pristine. Even on the walk down, I see in a lot of the areas that there are plastics and things like that, but they're the macroplastics.
Yeah, definitely. So macroplastic is usually above 5 millimeters in size, and it's very visible, and you might see it as like a bit of plastic bag or a bit of food packaging and stuff like that.
So the issue with plastics is that they don't break down, they break up.
They break up into smaller fragments, and what we're mainly looking for here is what we call microplastic, and that sort of plastic we're looking for is usually between 1 mil and 5 mil in size. Plastic that size in the environment is very hard to find. It's very transportable. So even if it's in a place like this, it may actually end up later on in your saltwater estuaries and your oceans, and then being swallowed by fish and native mammals and sea turtles and things like that.
And working its way up the food chain.
Working its way up the food chain. It's very easy to be ingested along with food. And because some of it is different colours, it might be mistaken for food in the environment as well. There is plastic, obviously, can break down again and again into even smaller pieces. But at the moment, we don't really have an easy way to sample that. So we're sort of restricting our search to plastic that we can see with the naked eye. So what we're doing here is we're taking sort of the top 2 centimetres of sediment. We're going to put that into our sample bags here. We're going to take that back to the office, back in the lab, to try and identify all those small bits of plastic. We'll do a massive check on all that sample, and it can take quite a few hours. And then we just record every single bit of plastic that we have and what we think the type of plastic that is. We get those results off to AusMap so they can add those to the national database sites that have microplastic. We also pick up macroplastic when we're doing this testing and record that as well.
So in order for these results to be useful in a national database, they need to be consistent?
Yeah, so we did our initial training with AusMap, there were other organisations there as well, and they've gone through the procedures with us to ensure that we have our correct translate lengths, the number of quadrats, randomised number generation, so it's all consistent throughout that database.
And this is a program that citizens can be involved with through citizen science and really start to help paint that picture of the scale of the problem and hopefully help us find some solutions.
Yeah, absolutely.
Yeah, definitely. So we're even planning events where we're going to use this style of testing to teach kids how to recognise microplastic in the environment. But we do want to use the procedure that AusMap has developed in community education so that we can actually highlight with the community that there is a problem with microplastic. They just may not be aware of it.
Microplastics are a global problem, and they've recently received some attention in the media, which allows projects like this to go ahead. We've spoken to a few people today that are part of the solution, and we'd love it if you could be part of it too. So Soph, there's a lot of work to be done just trying to define the problem. How can people get involved?
Yeah, well, we can. People can get involved in our OzMap microplastic sampling program, so you can come along, contact council. If you know of a creek where there might be some big sandy sediment deposits that you want to look at, or you can come and check out some of our sites that we already know. You can come, help sample and participate. And then once we know what's going on in our environment, we can figure out ways or prioritise which things we need to do to help make sure that we keep our lovely natural areas as good as they possibly can.